Okay. I believe I said okay. What could X be? Could be positive 5, could be negative 5. So really, it could be the same thing, or it could be the negative. What's that? No, you don't have to, because we're going to look at a couple others. What could X be? 3, or negative 4. Negative 4 plus 1 is negative 3. Negative 5, because negative 5 plus 1 is negative 4, and when I take the absolute value. Or you could think of it like this. Like, think what plus 1 is equal to 4, because its absolute value is also 4, so X is 3. You guys got that one pretty quick. But remember, this could also work out to negative 4. So X plus 1 could also work out to negative 4. We'll just solve it. X equals negative 5. Okay? So that's how we solve absolute value equations, is we actually make two equations. So we remove absolute value bars and make whatever the expression that was inside the absolute value bars equal to the positive of the right-hand side. And we remove absolute value I should say absolute value, not values. Remove absolute value and make expression equal to the negative of the right-hand side. And then you just solve each equation. However, with absolute value, just like when we solved radical equations, okay, you have to check your solutions, because sometimes the solutions you get won't work if you plug it back into the original, like what happened with radical equations sometimes. Okay, let's look at just a couple of examples. Pardon me? So if we're asked to solve this, we can do it algebraically, which is what we'll usually do, where we make two equations. As we take out the absolute value bars, x minus 3 will equal positive 5, and x minus 3 must also work out to negative 5. Because when we take that absolute value, we get positive 5, which is a solution. So solve each one. X equals 8. X equals -2. But you have to check. Does the absolute value of 8 minus 3 equal 5? Because remember, you plugged one of the answers you got back into the original. And does the second one, minus 3, taking the absolute value, work out to 5? Well, 8 minus 3 is 5. Absolute value is 5. Yeah, that's good. 5 equals 5. And here, -2 subtract 3 is -5, and the absolute value of -5 is +5. So that works out too. So we're all good. Both of these solutions work. So they're good answers. We did this with quadratic equations. We could also solve them by graphing. And how did we do it by graphing? We graphed each side of the equation and saw the points where they intersected each other. So graph each side of the equation absolute value of x minus 3 equals 5. And find points, or point, if any, of intersection. Those are your solutions. We already know what the solutions are here. It's 8 and -2, which means when I graph each side of this equation, they should intersect at 2 points. So we need to graph remember, to graph a side of an equation, just toss a y equals in front. We need to graph this. And we need to graph this. Well, let's take the easier one first. How would you graph this? Y equals 5. What kind of line is it? Horizontal line, y value is 5. So just go up to the graph, find a y value of 5. Well, the easiest one is right on the y-axis, and draw a horizontal line through it. So that's y equals 5. For the absolute value one, remember we got to do this in 2 stages. We have to graph y equals x minus 3 first. And how do we graph this? From what we did in grade 10, the slope-intercept formula, where we graph the y-intercept and we use the slope to find a second point on the line. What is the y-intercept of this line? -3. What is the slope as a fraction? 1, but as a fraction, because we're going to do rise over run, 1 over 1. So this is 1 over 1. This is -3. So we graph -3, and then we go up 1, because it's 1 over 1, and to the right 1, and try and be as accurate as possible. But am I done? No. I've only graphed x minus 3. When I do the absolute value, what happens? Everything below flips above. So this basically disappears. And it goes up here, and it forms a V shape. So it's going to look like this. No, I'm a little bit off. A little bit off. It's going to look like that. That's the absolute value graph. So it intersects at 2 points. Those are the solutions. What are they? X is -2. That's one solution. X is +8. That's another solution. So that matches up with what we did algebraically, which it has to. You can't use two different methods and get two different answers. That makes no sense. Okay. Remember, we did this type of graphing with quadratic equations. That's something that you're going to have to be familiar with on the exam. Okay. Anybody still need this? Okay, let's graph a couple other ones. Or sorry, not graph. Solve, and this time we're going to use algebra. We're not going to graph. So we're going to make two equations. One, it's going to look exactly the same as the first one, as the original, without the absolute value. The second one, we take the negative of the right side. And you've got to take the negative of everything. You've got to take the negative of the 5 and the -3x. So now we solve both of these equations. Well, remember, there's no quadratic equations here because it's just x, no x squared. So pull this over to make it 5x minus 5 equals 5. Add 5 to both sides, so 5x equals 10. Divide both sides by 5. This solution is x equals 2. This one, well, before we start pulling things over, we got to run the negative through the parentheses, change all the signs. Pull the 3x over by subtracting 3x, so I get -x minus 5 is equal to -5. Add 5 to both sides, so I get x is equal to 0. Sorry, -x is equal to 0. Well, if -x is equal to 0, what's x equal to? 0 as well. You just divide both sides by -1. So those are the two I have to check. Because remember, you have to check these. So pretty straightforward to check. So it's going to be, does the absolute value of 2 times 2 minus 5 equal 5 minus 3 times 2? That's how I check this one. To check this one, does the absolute value of 2 times 0 minus 5 equal 5 minus 3 times 0? right? 2 times 2 is 4, minus 5 is negative 1. What's the absolute value of negative 1? 1. And what is 5 minus 3 times 2? Minus 1. No good. No good. It's gone. And 2 times 0 is 0, minus 5 is negative 5. The absolute value is 5. And minus 5 minus 3 times 0 is still 5. That's a good one. So x equals 0 is the only answer. Yeah. Oh, no, it's an x as in wrong. Yeah. What do you think you'd do with this one first? What's that? Make it 2 equations, but don't we want the absolute value by itself? Move the 12 over first. Get the absolute value expression by itself before you make your 2 equations. Bless you. Now you're ready to make your 2 equations. 3x minus 4 is equal to negative 3. Same equation without the absolute value bars. Or the 3x minus 4 is equal to negative 3, which is 3. Okay. So add 4 to both sides, I get 3x equals 1. Divide both sides by 3, I get x equals a third. That's a potential solution. Subtract 4 from both sides, I get 3x is equal to negative 7. Divide both sides by 3, I get x is equal to negative 7 over 3. That's another solution. Potential. But I got to check by plugging back into the original. So does 3 times 1 over 3 minus 4, and then I take the absolute value of that plus 12, does that equal 9? What's up? What? Here? Oh, sorry. Thank you. Yeah, you're right. And then I got to check, does 3 times 7 over 3 minus 4, absolute value of that plus 12 equals 9? So you got to know your fraction, how to multiply fractions by whole numbers. What's 3 times 1 over 3? 1, right? Because it's 3 over 3, which is 1. So 1 minus, I'm going to write this out in a couple of steps. 1 minus 4 plus 12, does that equal 9? So 1 minus 4 is negative 3. The absolute value is positive 3. Does 3 plus 12 equal 9? I think we can pretty much establish that's a no. We don't have to go any further. I think we can see that's obvious. This one, 3 times 7 over 3, gives us 7 minus 4 plus 12. Does that equal 9? 7 minus 4 is 3, the absolute value of 3. And once again, I get 3 plus 12 equals 9. What is my answer? No solution.
Why did you do yes,
Oh no, because when you when you're checking, when you check, you plug it into the original. You don't change it. Yeah, you don't. No. The only time you change from positive to negative is when you're removing the absolute value bars. That's the only time. That's a good question. And this one kind of makes sense because if you think about it from this step right here, how can I take the absolute value of something and get a negative answer? I can't. There's nothing that I could plug in here, take the absolute value and get a negative answer. Because every time you absolute value it, it's positive. So when I look at this, I say you can't do it. Okay? I mean, we've proven that you can't do it. Okay, last one. Oh, we got a quadratic. Why did I say that? What made me say that? Why did I say that? Why did I say that? And why did I say that? Once again, why did I say that? What's that? You have two. Two. You have an x squared. So right away, I'm thinking factoring at some point. Absolute values by itself, so let's take them out. Identical equation without the absolute value. But then the second one, you change the right-hand side to negative. How do I solve this? Bring the 1 over. And factor it. What would it be? I need two numbers that multiply to -1 but add to -2. There's only one possible pair of numbers that multiplies to -1. 1 and -1, right? But they don't add to 2. Uh-oh. Can't factor. Uh-oh. Now what? Quadratic formula. Do we remember what it is? X equals. You will get this formula. Okay, you don't have to memorize it, but you remember? Negative b plus or minus square root all over 2a. So this would be an example. If I gave you a question like this, I wouldn't ask you to check them. I would, because it's very difficult to check this one when you've got radicals. Okay, we'll just assume that the checks work. So x equals negative b, so -2 plus or minus -2 squared minus 4 times 1 times -1 all over 2 times 1. So that gives me -2 plus or minus. Remember, when you square this, it's 4, not -4, it's 4. And this is plus 4. So this works out to 8. What's that? Oh yeah, sorry, +2. Thank you. Now what? Don't you dare say cancel the twos. Yeah, you have to simplify the root 8, right? And root 8 breaks down to root 4 times root 2, which is 2 root 2. Now, remember, if you're going to cancel, you got to be able to cancel out everything. If you try to do 2 here, you can cancel the 2 out here and here, but not here. Not until it looks like this. Now they can all go. And they all go down to 1. And I get 1 plus or minus root 2 over 1, which is just this. Good refresher, because you're going to see it. You know you're going to have to use it. You're going to see a question like that. I guarantee it. Guarantee. Okay. Don't write so fast. Take it easy. You're gonna hurt your hand. You okay? All right? Okay, you're good. Are you thinking about your prefix speech? All right. This one, we got to move the -1 over. I have better news here. This one you can factor. I'm not interrupting you by talking, am I? Okay. Okay. Terribly sorry if I am. Well, I appreciate that it's okay. How would we factor this one? This one will factor. Two negatives? Okay. And 1, 1. So the answers are going to be the same for either one, x equals 1. And again, I wouldn't have asked you to check this one. Okay? Because this is pretty nasty to check. Yes. Because you know what you'd have to do to check it? Don't write this down. Yeah, I wasn't too worried about you. You'd have to do 1 plus 2, root 2 minus 1 plus root 2 squared, minus 2 times 1 plus root 2. And then you'd have to take all that absolute value, and you'd have to see if it equals 1. And then you'd have to do this. Remember, there's 2 answers here. You'd have to do the same thing all over again for 1 minus root 2. But like I said, this is nasty. So I wouldn't ask you to check it. Okay? But don't be surprised if maybe you see a quadratic inequality, absolute value. Okay? Sorry? I will make it clear. If I gave you one like this, provided that some of you remember to read instructions, and I know some of you don't, I will say you do not have to check your solutions. If I want you to check your solutions, I will say so. Again, those of you that don't bother reading the rest of the question, I'm just scanning the room. I just happened to land on you.
You're probably staring at me.
No, I'm not. That's a little egotistical, isn't it? Could be worse. Big words. Oh, thank you. Okay. And no, that's not going to happen. Anything else you want to talk about before I stop recording? What are you running for again? Ballivard? Ooh, that's my house too. Yeah. No, mine's got no.
Oh, you forgot your own house?
I forgot my own house. It's mine's Braemar.
Stop.
I'm sorry. B and B, you know, it's.
I think also teaming against vaping, so.
What's that?
She's also a teen against
I support it. I support the vote.
But isn't pretty much everybody running unopposed
Yeah.
for every position?
Even Gabby and Anna are the only. Yeah, I was trying to.
School or sports? Is it because nobody wants to run against each other? Is it because there'd be too much drama? You know, I just said the word drama. Yeah, you just fix that. Yeah, fix your face there. I did. It's right across from me. How can I miss that? It's not my classroom, so I'm offended. Why didn't you do it in my classroom? That's okay. I'm really not offended. You know I'm still recording, right? It says what? Oh. I have a t-shirt at home that says Trig Camp Counselor. I got that from a student. Because I used to, when we did it in grade 10, I used to call it Trig Camp. That's when everybody liked Trig, remember? When Trig was easy. And then we did Trig this year. And then it upset many of you. Turkey biscuit. Oh, you should have seen the pies. They were from Goodies. You still got grade 12. Easy, princess. What? Because we're not allowed to, apparently. She. Whoa! Don't get salty with me. Don't get shirty with me. That's a great story. I'm okay. Anything else before I stop recording? Vote Ken Mead for Braemar House Captain.